Okay, so I know law of exponents is going to be coming up in instruction in college prep math, so I'm gonna make a brief little video going over 5 examples to showcase a strategy that you could possibly show your students so that they could better organize their work. You could also just give them the exponent rules and see if they can connect what to do by looking at the exponent rules. So I'm gonna go through. This strategy was seen on one of the campuses in their Algebra I class, but it's called a fence post and it helps students just organize their work. So when I look at the first expression here, I can see that we have the variable m, the variable n, and the variable p. So I'm going to create 3 parts of my fence post, one for each variable, and then I'm going to fill in the parts of my fence post. So I have m squared in the numerator, m to the 5th power in the denominator, n cubed, n squared, p to the 4th power, and p to the 7th. And so from there, I can focus on one variable at a time. So for example, I'm going to focus on the m's. M squared is just m times m. M to the 5th is m times itself 5 times. And then after that, I can go into n's. N cubed is n times n 3 times. N squared is twice. And then p to the 4th power is p times itself 4 times, p to the 7th 7 times. And then from there I can realize that anything divided by itself is 1. So I can see that m divided by m would be 1, and I can start canceling out variables. So m divided by m is 1, m divided by m is 1, n divided by n is 1, n divided by n is 1, p divided by p is 1, p divided by p is 1, p divided by p is 1, and p divided by p is 1. So from there, I'm able to write my answer because I have m times m times m in the denominator, which would be m cubed. I have 1n in the numerator, which would just be n. And I have p times p times p in the denominator, which would be p cubed. So it just helps students connect their work and organize their work. So hopefully there they would see that if we are dividing exponents with the same base, we could subtract their exponents. All right, the next problem, I would also do a fence post, but I notice I have 2 variables, k to the 12th and b to the 8th, and both of those are being raised to the 1/2 power. So I would do k to the 12th power, and then b to the 8th, and both of those terms are being raised to the 1/2 power. So from there, I would say if we have an exponent being raised to another exponent, we multiply. So I would say that'd be k to the power of 12 times 1/2, and that would be b to the 8th power times 1/2, which would then be k to the 12 times 1/2 power would be k to the 6th power, b to the 8th power times 1/2 would be b to the 4th power. So then our answer would be k to the 6th, b to the 4th. So hopefully they'll connect that if you have an exponent raised to another exponent, you just multiply those 2 exponents. All right, the next one, we have 2 expressions being multiplied. So here is another good chance or opportunity to use that fence post so that they can see that when we're multiplying, we can really just start combining the expressions. So, but here I'm going to have a 2 and a 5, an x and an x, and a y and a y. Those are my terms and coefficients. So I'm going to start with the coefficients, 2 times 5. And then I'm going to go to the x's. I have x to the 7th times x to the negative 4th. And then y is y to the 6th times y to the 3rd. And so from there, I can go 2 times 5 is 10. X to the 7th times x to the negative 4th. Well, there is an exponent law where if you have a negative exponent, you take the reciprocal and then make the exponent positive. So that would go from x to the negative 4th in the numerator. It would be the reciprocal, so now it would go into the denominator, but the exponent would be positive. And then we have y to the 6th times y to the 3rd. And so you could have students expand it out again, or they might see that here I'm going to subtract, and then here I'm going to add the exponents. So I would have 10x cubed y to the 9th. All right, again, now we have some fractional expressions and we're just multiplying them. So again, another opportunity to kind of look and decide what are our variables. I have an m variable, I have a p variable, and I have n. So what I can do now is I can still draw that fence post, but I'm going to focus on each variable one at a time. So before I do that, I'm just going to rewrite it as one big fraction. So m to the 7th, p to the 9th, times n to the negative 8 power squared, n to the 4th times m to the negative 3, or the negative 3rd power, p to the negative 5th power. So now after I have it written as one combined expression, I'm going to start separating, and I'm going to start with the m's. So I see I have the m to the 7th here, and another m term there. So m to the 7th is in the numerator, m to the negative 3rd is in the denominator. Then I'm going to go to the n's and find where my n terms are. So I have n to the negative 8th power squared and n to the 4th. And then last I have the p terms. So p to the 9th is in the numerator, p to the negative 5th power is in the denominator. So now I'm just going to go and focus one-on-one each term. So here, m to the 7th is in the numerator, m to the negative 3rd is in the denominator. So with the negative exponent, again, we take the reciprocal. So this is going to move into the numerator. So I have m to the 7th times m to the 3rd. Then I have negative 8, n to the negative 8th power squared. So that is really just like n to the negative 8th times n to the negative 8th. So what I can do then is, again, when we have exponents with a negative, or if we have an expression with the negative exponent, what you do is take the reciprocal. So if it's in the numerator, it's going to go to the denominator. So I'm just going to take both of those, put them in the denominator, and then it'll be a positive 8 as an exponent. And then n to the 4th. And then the same thing with here with this exponent. So p to the negative 5 is in the exponent, so we're going to bring it up in the denominator, so we're going to bring it up into the numerator. So from there, I can say when we are multiplying exponents with the same bases, we add. So that'd be m to the 10th power. And then here, same base of n, add the exponents. 8 plus 8 is 16, plus 4 is 20, so n to the 20th power. And then here again, p is the base, same base, add the exponents. 9 plus 5 is 14. And there would be your answer.